The next lesson is about angles and angle measurements. You remember when I showed you the calculator before and I said when you go to mode, you can be either in radians or degrees. Well, I want to talk a little bit about the measurement of radians. We're used to degrees. We're used to thinking about a circle as being 360 degrees if you go all the way around. But the reality is that's actually an artificial measure. I think it's likely that at some point someone decided that a circle should be 360 degrees because there's about 360 days in a year. So it was based on something like that. The radian is actually a more natural measure of the circle. Okay, but we're not very used to using it. We don't use it very often. So let me show you what a radian is. Okay, if you take a circle and you measure the length of this radius, okay, whatever this radius is, if you put that length on this circle, so the arc of the circle and the radius these are the same length. When you have that, you end up with a degree measurement. Well, I don't know how many degrees it is, but this is called 1 radian. Okay, so you can measure a circle in radians. Now, if you look at that, that looks like it's about 60 degrees, but we don't know that for sure. We have to figure that out. I'll show you how to do that a little bit later. What we know is if the radius and the arc length are the same, it makes 1 radian. Okay, and by the way, 1 radian is about 57 degrees. So yeah, about 60 degrees. Okay, so the radian is considered a natural measure of the angle because it's related directly to arc lengths and radiuses. Okay, so let's look now, why do we have this term called pi? Well, if you take a circle, remember I told you that 1 radian, let me use a different color. 1 radian is when the radius is the same as the arc length. Well, if we go ahead and start moving around the circle, here we have 3 radians. That's going to be almost halfway around the circle. In fact, halfway around the circle, if we wanted to go all the way around here, you would get 3.14 radians, or pi radians. Okay? If we kept going all the way around the circle, we know that's 360 degrees. This is considered 2 pi radians, which would be about 6.28 radians. Okay, now I know that seems weird. We're not used to it. It's not something we've done before. Let's talk a little bit about how do we switch back and forth. How do we get more familiar with what a radian is? Well, here are some measures that are very common to us in degrees. Okay, now I mentioned that 360 degrees, the equivalent is 2 pi radians. This is around the circle once, 2 pi, or 6.28. These things are the same. This is what we call an exact measurement. Okay, and this is rounded off. Alright, if we go around half the circle, 180 degrees is pi, or 3.14 radians. Then 90 degrees is half of pi, etc. Okay, now you don't need to memorize these. I would say you should have these two memorized, because if you do, you can figure out all of the other ones. In fact, we're going to use this formula right here. Okay, if we want to figure out how to change from degrees to radians, we're going to use this little ratio here, knowing that pi radians is 180 degrees, right? If you think about our circle, okay, halfway around the circle, we know that's 180 degrees. We also know that it is pi radians, 3.14 radians. Okay, so let's convert to radians. 50 degrees, how many radians? Well, we'll use this formula we've got here. It says number of degrees over 180, so we have 50 degrees over 180 degrees, and this equals, remember that 180 is pi, and I don't know how many radians 50 degrees is. So this is my ratio. I know that these two equal each other. Okay, and then I can use that to figure out, well, how are they related up here? Well, how do you solve a ratio like this? Well, this should be familiar to you. We use a technique called cross-multiplying. I hate that term because it's not really cross-multiplying. We're actually solving for x. But the easy way to do this, it's kind of a shortcut, is that we just multiply in an x here. So if we go 50 times pi, we get 50 pi. And if we get 180 times x, you get 180x. And remembering that we want to solve for x, we're now going to divide both sides by 180. So this cancels out, and we get x is... Alright, now here's a little trick for you. That's the answer. Okay? If you want to use a calculator, it's going to become a non-exact value because you're going to round off. Okay? So I'm okay if you just leave it like this. Now you could reduce the fraction, right? We could cancel out 10 here, and we could say this is 5 pi over 18. But I'm not going to be too worried about reducing fractions. Okay? Now let's try 270. Okay, we'll use the same ratio. So those two are equal, and we put 270 here, and let's figure out what x is. Okay, so we're going to cross multiply. You get 270 pi is 180x. Oops, it should be x. If I divide by 180, I can leave it as 270 pi over 180, or I can reduce that, and it turns out that x is 3 pi over 2. Okay, that's the reduced fraction. Okay, let's skip that one, because it's just a ratio. We'll do the exact same thing now going the other way, so use the same ratio. 180 is pi, but this time we have the radians. So I'm going to put 5 pi over 4 here, and we'll put x there. Okay, so we'll cross multiply. I get pi times x equals 180 times 5 pi over 4. And then if I want to get x by itself, I'm going to divide both sides by pi. Okay, and I get x is, well, 180 times 5, this is 900 pi over 4 over pi. Well, these pi's cancel out, so you get 900 over 4, which is 225 degrees. Okay, let's try another one. Again, we know that 180 is pi. Put 1.25 there, put x there. If we cross multiply, we get x pi equals 1.25 times 180. That's going to be 225. Okay, and so then if I went x, it'll be 225 divided by pi. Okay, now since this is degrees, I would say this is going to be a calculator question. We'll just take that. Let's go, what is 225 divided by pi? 71.6 degrees. We'll say 72 degrees. Okay? Alright, a few more questions here. It says, the measure of an angle is 1 radian. Calculate the measure in degrees. Well, we already told you that. It's 57 degrees, but let's show you where that comes from. Okay, so we're told that there's 1 radian. Let's figure out what x is. Okay, so we cross multiply. We get 180 is x times pi. If we divide both sides by pi, you get 180 divided by pi, and that gives me 57 degrees. Okay? Now example 2, calculate the value of each angle in radian measure and leave as an exact value. So when you see the word exact value, that means no calculator. okay? And you might want to do this by remembering this. You know that 180 is pi. So how does 90 compare to 180? Well, I'm hoping that we can see that 90 would be half of 180. So what is x going to be? It's going to be half of pi. So x will be half of pi, like that. Now if you don't see that, let's actually do the math. Let's see where this comes from. Okay, so we cross multiply, we get 180x is 90 pi. Okay, if I want to divide by 180, I get x is 90 pi over 180. And I could leave it like this, but you see that 90 and 180 are exactly half. So you could write it like that. Okay. Now, before I do the next one, 45 is half of 90. So x should be half of pi over 2. What is half of pi over 2? Well, if this is half of a pi, I want a quarter of a pi. So in this case, x is going to be pi over 4. But again, sometimes our mind goes blank on us. Let's actually do the math. So put 45 there, put x here, cross multiply. You get 180x is 45 pi. If I divide both sides by 180, I get x is 45 pi over 180, which you could leave, or you could see that this is pi over 4 reduced. Okay, so I think you've seen sort of enough of these. I just want to highlight one difference. So this one says to 2 decimals. Okay, when you see exact, this means no calculator. Okay, and this one says you can use a calculator. Now, you could use a calculator to go 45 divided by 180 here, but the point they're saying is we don't want you to go pi divided by 4. We don't want you to give this as a decimal value. Okay, whereas this one, we can. So let's try one here. So it's 240x, cross multiply, we get 180x is 240 pi, and so x is going to be 240 pi divided by 180. And you can use a calculator for that. So you're going to get 240 times pi divided by 180. Okay, and we'll go 4.19. So x is 4.19. Okay. So try these next two. Okay, there are the answers. If you're not sure, bring it to me. Let me check it over. Okay, example 4, determine which angle is larger, 3 pi or 8. Well, this is interesting because these are both radian measures. Okay, these are both radians. One of them is 3 pi and the other one is 8. Well, this is 8 radians. Nothing we can do about that. But 3 pi means 3 times pi. So let's go 3 times pi and see what that equals. 9.42. Well, now you can definitely see which one is larger. This one. Okay. Example 5. Use radians to state the domain of a graph. Okay, so again, we looked at the sine and the cosine graph the other day. And if you remember, we did this. We had, these were some of our measures. You can check back in your notes to look at those, look at the graph and the values. But we want to change this to radians right now. So if this was degrees, how far is this? How much farther do we go? Well, the thing you should know about these sine graphs is that they are perfectly symmetrical. If this is 360 degrees, then this would be another 360 degrees. This would be 720. Well, this is half of that extra 360. So what I'm going to do is I'm going to add 180, and I would end up with 540 degrees. But that's not what it asked for. It said, what is the domain in radians? Okay, so we're looking for what is this distance in radians. Well, we can use our formula, and we want to put 540 here. Figure that out. So we'll cross multiply, get 180x is 540 pi. X is 540 pi divided by 180. So x is, well, what if we did this? This is going to be 3 pi. Alright, so you end up with 3 pi, which should make sense because you know that 180 is 1 pi. You know that 360 is 2 pi. So this would be 3 pi. Okay, let's check the next one out. Again, this is supposed to be a sine graph. Now, it has moved over. It does look a little bit strange because we've never seen anything over here. But that's okay because the sine graph actually continues on in both directions forever. Okay, we know that from here to here is 360 degrees. This will be another 180 degrees, so 540 here, and then we'll end up here at 720 degrees. Okay, and then we go backwards, negative 180 degrees. So if we were looking at what is the domain here, the domain is from negative 180 degrees up until 720 degrees. Okay. Well, what is that in radians? Well, this will be negative pi up until, okay, here was 1 pi, here was 2 pi, here was 3 pi, here's 4 pi. Okay. So, some more homework questions, just getting used to using radians. If you could do homework assignment number 2, we'll continue with this in the next lesson.